Okay, this is AP Chemistry Chapter 8, the atom. Here's a look at some of the things we will be studying. As you take a look through this, you'll see that this isn't your standard protons, neutrons, and electrons. We're going right into some of the inner workings of the electron, the wave-particle duality, how it has a lot of wave properties, a little background on wavelength, frequency, and the speed of light, and directly introducing that into Planck's constant formula. We'll also show a combined formula, atomic emission spectrum onto the Heisenberg uncertainty principle, applying this to some simple concepts like electron dot structures. AP Chemistry does focus on photoelectron spectroscopy. That's something that's kind of unique to AP Chemistry. And then there's a review. Let's take a look at some of the formulas that we'll be covering in this unit. There's the wavelength formula. The speed of light is equal to wavelength times frequency. We can use Planck's constant formula, where energy is equal to Planck's constant times the frequency. And since frequency is equal to that, you can combine them into a combined formula right there, which is handy. The Balmer formula plays a central role in the discovery of the shell-like properties of the atom. And the formula that I use most frequently is that the wavelength in nanometers is equal to 1 over the Rydberg constant, that number times 1 over inner squared, 1 is 1 over outer squared. Those are the whole numbers that really ushered in the quantum revolution, where they represent the inner and outer shells respectively. And there's similar formulas that are shown here. You can copy those down. Here it is expressed in terms of energy. The de Broglie formula is interesting. We can find the wavelength of just about anything by having it be equal to Planck's constant over the mass times mu here, which is just another form of the speed of light. They use c here, but mu there. Notice that this is an unusual interpretation of the joule here, where it's equal to a kilogram times a meter squared times divided by a second squared, which makes this formula actually work. So let's look at some of the formulas that we'll be using. Pause that if you need to copy any of them down. We'll use Beer's law in our first lab. Sometimes it's expressed as ABC, but here it's the extinction coefficient times the path lengths times the concentration. And that's a look at some of the formulas we'll be using. In our first lab, we'll be using Beer's law to determine the concentration of an unknown sample of food dye in drops of food dye for every 100 milliliters. And so I'll just skip over that, but that's the first lab we'll be doing. There's the formula. And then we can go ahead and begin with properties of waves. This will be a separate slide. That's a little introduction to the atom for AP Chemistry.